Finally, we have properties of alcohols and phenols. The only real properties that we're worried about right away, other than the reactions that they'll do here in a second, right? Most alcohols are water soluble, right? You should probably understand that already, since this thing is dissolved in water in a lot of drinks. But it's because of that hydroxyl group, right? That's polar, just like water's polar, right? So there's a polar bond there. The water nearby is also polar, and positives are attracted to negatives. Like dissolves like. Ethanol does dissolve in water. But if there's more than 6 carbons attached to that hydroxyl group, if it's 1, 2, 3, 4, 5, 6, 7, 8, I don't care how long that chain is, right? If it's more than 6, then this part of the molecule that's actually very nonpolar kind of outdoes that small hydroxyl group that is polar, and it makes it no longer soluble. So as long as it's small, it's water soluble. If there's less than 6 carbons, it's probably soluble in water. But if there's more than 6, as it says here, it's going to be insoluble. Right? Otherwise, down below when it says about boiling points, essentially, like you would know that propane is a gas at room temperature, right? And we talked about how it had to be at least 5 carbons before it could be a liquid, right? But when I say boiling points are higher than hydrocarbon with the same number of carbons, I don't know if I meant same number of carbons. I meant same number of atoms, really, because I would usually compare this 3 carbon chain versus like 2 carbons and then oxygen. So that's my ethanol versus this propanol. And ethanol, right, is a liquid at room temperature. If you had pure ethanol, which would be kind of hard to do because it really likes water, but if you had pure ethanol and only ethanol, it would be a liquid at room temperature. It would have a relatively low boiling point compared to water, but it would have a much higher boiling point than my propane, right? So if I was comparing those two things, which one has a higher boiling point, it would be this guy, right? It's probably a liquid at room temperature and would even, right, unlike, excuse me, the propane on the left, that would be a gas because it has smaller attractions. Otherwise, if I was comparing that 5 carbon chain, I'd be comparing it to like the 4 carbon, the butanol, right? So it has the same number of atoms, 1, 2, 3, 4, 5, right? Non-hydrogen atoms is essentially what we're talking about. So that 5th atom is my oxygen over here. But since that oxygen, unlike this carbon over here, and that hydroxyl group that is involved is very polar, there's attractions between these molecules, and this one would likely have a higher boiling point. Otherwise, I don't usually throw those on any quiz or test for this. So it's not that big of a deal. It's just understand when you're comparing boiling points from here on out, we're probably talking about similar number of atoms. So when I say same number of carbons, I probably meant atoms here, but we'll get the gist of that.